Today I am going to give you the demonstration of potentiometry experiments. For this, first thing is we need potassium dichromate. This is the potassium dichromate solution which is to be filled in this burette. So the first burette has to be filled with this potassium dichromate and 25 ml of FAS is taken in a beaker, and to this we have to add 1 test tube of dilute sulfuric acid to maintain the acidic media. After adding this, we must immerse two electrodes. One is a platinum electrode, another is a calamine electrode. This is a platinum, this is a calamine electrode. These two electrodes is immersed in this, and after immersing, this has to be connected to the potentiometer. This is called a digital potentiometer. We already connected it. So after this, we have to immerse this small rubber tube to mix up the solution during the course of titration. So then we have to switch on both of these, stirrer and then this instrument. Then we have to note on the initial potential value. This is the potential value 291, and this is the observation. So initial value, it is around 297. We have to note down. We have to wait for a few seconds. After noting down this, we have to add this potassium dichromate in the increment of 0.5 ml. So now I am adding 0.5 ml of potassium dichromate into the beaker. After adding this has to be mixed well with the help of this rubber tube. So it is mixing, and then gradually the potential values goes on increasing. So like this continuously we have to go on adding this potassium dichromate in the increment of 0.5 ml. After each addition we have to mix it well, and we have to note down the rise in the potential values like this. So this is 320, 321, etc. So like this until getting a sudden jump in the potential value, we have to go on adding this potassium dichromate in the increment of 0.5 only. So whenever the potential values jump suddenly, maybe around 4.5 to 6 ml, we have to stop doing this. So after that, if we want, we can add few more ml, that is 2 to 3 ml in excess. So we have to stop at that stage. So at the end here, we are going to get the solution in a greenish color due to the formation of chromic sulfate. So this is what the experimental part. After that, we go to the observational calculation. This is how we want to do the observational calculation. This is the first column, as column potassium volume of potassium dichromate we have already given in the lab manual. This is the potential values, volume of potassium dichromate. Second one is potential values E, initial value rises, and here there will be a sudden jump in the potential values around 5 ml. We can observe here 690 becomes 746. So the next column is delta E, that is change in the two successive potential values that has to be filled in this third column. Fourth column is change in the volume. So this first column difference we have to take here, that is 0.5 minus of 0, this is 0.5 like this. So two successive change in the volume of the potassium dichromate we have to take, and we have to fill in the fourth column. The fifth column is about delta E by delta V. So this is how the fourth column is divided by fifth. Third column is divided by fourth column. This gives the fifth column values. We have to plot the graph for these values. So if you plot a graph, the graph will be obtained like this. In the x-axis we have to take the volume of the potassium dichromate. So in the y-axis we have to take the delta E by delta V. We are going to get this curve. So this curve is called the equivalence point. From this equivalence point, we will calculate the amount of the weight of FAS present in the solution. So it is like this. This is what the calculation part. Thank you.